Okay, I want to spend a little time talking about Venn diagrams. So here are some pictures of a Venn diagram. These are going to be extremely helpful when we do some problems in Chapter 15. So the first thing I want to show you, and I'm going to be using a little bit of set notation as well. I want to talk about the probability of A or B. All right, and so this, when we have an or, we use the word union. So this is the probability of A union B, and we have a notation for that in set theory, and it looks like a U, probability of A union B. And if you think about this with this picture that I have, the probability of A would be everything that's in A. So here is circle A. So this would be the probability of A. The probability of B would be everything that's in B. The probability of A union B, which I have here, consists of everything that's in A or everything that's in B. So we get the probability of A plus the probability that's in B, except we have a problem. And the problem is this center part was added twice. And so what we have to do is we have to get rid of that part. I'm going to jump down here to this next, probably should have started here, and that is the probability of A and B. The probability of A and B means that both are true. So we have an event that's part of A, and at the same time it's also part of B. So this is intersection, and you could probably guess which region I'm talking about. The symbol we use is this. So we have the probability of A intersect B, is how we would say that. That's the part that's common to both. So we would be talking about this region here. It's in A and it's also in B. So let me move back up to what I was working on here. The part that is common to both, we call that A intersect B. So this right here is actually a formula, and it is called the addition rule for any two events. Okay, this works for any two events. If you want to know the probability of A union B, or we can think of it as A or B, it's the probability of A plus the probability of B minus the intersection, minus the probability of A intersect B. Now we do have a special case, which this illustrates. Notice these don't overlap. So these are called disjoint, or sometimes we use the word or the term mutually exclusive. And if they're mutually exclusive events, or if they're disjoint events, that means they have no outcomes in common. So in that case, if you wanted to know the probability of A or B, it's the probability of A plus the probability of B. Now if you subtracted the part like we've used up here, if you subtracted the intersecting part, well, there is no intersecting part. So the probability of A intersect B is 0 because they're mutually exclusive. So the formula just becomes this. So this is true for disjoint events only. Then you don't have to subtract the overlapping part because they don't overlap. So we're going to use these ideas. We're going to solve some problems from the book. So you might want to get your book handy. Okay, so we've got problem 3. Real estate ads suggest that 64% of homes for sale have garages, 21% have swimming pools, and 17% have both features. What is the probability that a home for sale has? And then we have some different possibilities. I'm going to show you both ways. I'm going to show you with a Venn diagram, and you'll see how simple this is to do. And then I'm also going to show you with the symbols because I want you to be familiar with the proper notations for probability. So I'm going to use a G to represent has a garage. And I'm going to use a P to represent has a pool. And I'm going to draw a Venn diagram. So a Venn diagram, we have our circles. So I'm going to have a G and a P. Okay, and I'm going to look through here and it says 64% of homes for sale have garages. Well, that's this whole circle. Now I have to be careful because I'm not sure what number goes here and what number goes here quite yet. 21% have swimming pools, 17% have both. I'm going to start right in here in the center, and I know that 17% have both. I'm going to pause this and make this Venn diagram bigger. Okay, so I'm going to start with the part that has both. There are 17%, so the probability that it has both is 0.17. Then all I need to do is the probability that's over here, that they have a garage but not a pool. Remember, the whole circle for garage has to total up to 0.64. So you just take 0.64 minus 0.17, and you get 0.47. So these two things have to total up to the 0.64. Similarly, for pools, this portion over here would have to be 0.04 because these two parts together have to add up to 0.21. So here we have this picture that tells us right away, it's going to give us a lot of these answers. Now, one thing you have to consider is out here is my sample space. So remember my sample space, the whole thing has to add up to 1. So this box represents my sample space. So one of the things we're going to need to do is we want to know what percent or what's the probability that it's outside of the garage or pool combination. So you can probably imagine what you would do if we add these three things up, and then we need to subtract that from 1. And if you do that, you'll get 0.32. So usually I would start off, if I was going to do a Venn diagram, and I would just go ahead and calculate all those numbers and make my picture. Now, for part A, I want to know what's the probability of a pool or a garage. Now, the correct symbol is pool or garage. Okay, so that would be the notation I would use since I defined them with a G and a P. My formula says, I'm going to use the one for the addition rule. It's the probability of a pool plus the probability of a garage minus the probability of a pool and a garage. Okay, so that was just the formula. Plugging in those values, the probability of a pool is 0.21. The probability of a garage is 0.64. The probability of a pool and a garage, is 0.17. And if you go ahead and evaluate that, you will get 0.68. Now, remember, picture-wise, when we said the probability of a pool or a garage, if you look back at our notes here, it was these three things added together. So now look here, if you see 0.47 plus 0.17 plus 0.04, you'll see that you actually do get that 0.68. Okay, now let's look at neither a pool nor a garage. So that means you don't have a pool and you don't have a garage. So the notation for that would be you don't have a pool. So remember our little complement means you don't have it. So you don't have a pool and you don't have a garage. So that would be the notation. So the probability that we don't have a pool, and we don't have a garage. Now, I'm going to look up here instead of using a formula. So if we don't have a pool, so the probability we don't have a pool, well, let's take a look here, and we don't have a garage. Let's think about the region that we would be in. So no pool and no garage has to be out in this region, out here, no pool and no garage. So we find that we get 0.32. Now, let me point something out at this. Well, we'll come back to that. The next part is a pool but no garage. So that means we do have a pool and we don't have a garage. So a notation for that could be you have a pool and you don't have a garage. So that would be the correct notation. Using our picture, you have a pool, so that means you're in this circle. You do have a pool, so you have to be in this circle. But you don't have a garage, so you can't be in this part because these people, this is the probability of having a garage. So you would have to be in this region. Okay, so think about that again. You have a pool, so you're in this circle, and you don't have a garage, so you have to be in this portion of the pool circle, so we get 0.04. So that's how easy you can do some of these problems with a Venn diagram. Okay, let's go ahead and continue on this. We've got I'm going to make my Venn diagram here. So we have refrigerators and TVs. So dorm rooms, 38% has refrigerators, 52% had TVs, 21% had both. So I'm going to use an R for refrigerator, and I'll just call this TV. And we have, I'm going to start with the both part. So 0.21 is going to go in the center. And then we have to calculate what portion would be here. Well, 38% is in the refrigerator. We've already accounted for 0.21, so that leaves 0.17. Remember, the whole refrigerator circle has to total to 0.38. And over here for the TV, this would have to be 0.31 because the whole TV circle has to total to 0.52. Then we can get this space out here, which would mean neither a refrigerator nor a TV. If you add these three things together and subtract from 1, you get 0.31, and that would be the region that was out here. Okay, so now we want the probability of a TV but no refrigerator. So the probability of a TV but no refrigerator. Okay, so we have a TV but no refrigerator. So this is a lot like the problem we just did. We're in the TV circle. We exclude the refrigerator portion. We get 0.31. Okay, next one, a TV or a refrigerator, but not both. So a TV or a refrigerator, but not both. So that means we'd be looking at this, the 0.31 plus 0.17, but not both. So we leave out that 0.21, and we get 0.48. And for this last one, neither a TV nor a refrigerator. So we don't have a TV, we don't have a refrigerator. We already saw what that value is going to be, 0.31. And I know I didn't do symbols on those last two. I'm trying to keep it under 15 minutes here for this video to upload it to YouTube. So I will continue on with some Chapter 15 notes in the next video, but this should be enough to get you started on the Chapter 15 homework if you want to get started on that.